Hi, in this video I want to go over three things. Discuss the overview of Section 8, have a class discussion prior to the activity, which is going to focus on building function notation from context, and then introduce the activity, which is a gardening activity. So the two parts are going to be, for part A, interpreting function notation, and then part B, the algebra of functions. And so for part A, I had you guys do like a little introduction activity, which gave me some good insights in terms of how comfortable everybody was with verbal context, along with graphical representations, and also function notation through tables. And then also the Desmos activity gave me a good idea as far as how everybody feels about context and using function notation through that. And so the opening kind of sections is going to be going back to dealing with function notation in terms of a certain verbal context. And so the opening activity has a discussion, which I'll kind of talk through, which will hopefully help you when you get to doing the actual activity. So for this part, you can just kind of follow along and think through the process as I kind of explain it, and reference it in case you need to for the assignment. So for the discussion, we're going to go back and revisit something that we did at the beginning of the year. So I'll let you pause it and kind of read this over. So we're revisiting the round robin tournament problem, and we're going to let G be a function that defines the number of games played in terms of the number of teams. And so if you think back to the round robin problem, that's where we had every single team playing each other once, and then we had to figure out, for the first part in this case, how many total games would be played if there were 10 teams. And so you don't need to remember all the exact details, but just kind of maybe refresh yourself in terms of G is going to be the number of games played dependent upon how many teams there are. And so the significance of using the letter N in this case is the fact that N is going to be the number of teams, and also N has to be an integer, since we're saying that N represents a number of teams, so you can't have a fractional team, you can't have actually any negatives, so really this should be a natural number, so it should be all the positive integers for the variable N. G of N, since G is going to be the function that tells us the number of games played, G of N is how many total games are played if N teams are part of the tournament. And that should be pretty straightforward. I mean, G is the number of games, N is the number of teams, so depending on how many teams you have, G of N tells you how many total games will be played. So then if we wanted to compute G of, let's say, 8, that would be how many total games would be played if there were 8 teams in the tournament. And then 2G of 8. So 2G of 8 would be how many games would be played. Instead of each team playing each other once, 2G of 8 would be how many games would be played if each team played each other twice. Now let me pause and kind of explain why this is the answer to that one. So this was kind of like what most people did on the round robin tournament. And so you can see here that if every team plays each other once, for the first team would play a total of 7 games, the second team would play a total of 6 games, and then 5 games, 4 games, and so on. So if we're looking at 2G of 8, that means that Team 1 and Team 8 would play each other twice. Team 1 and Team 7 would play each other twice. Team 1, Team 6 would play each other twice. So that means you're basically doubling the number of games that are possible for Team 1. And then Team 2 and Team 8 would play each other twice. Team 2, Team 7, each other twice, and so on. So you're doubling the number of games this way. So really what you're doing is you're taking each possible game outcome and then doubling it. So that's why the previous answer had each team playing each other 2 times. Okay, so now back to this one. So G of 11 minus G of 8, this would signify if you counted the total number of games played by 11 teams and the total number of games played by 8 teams, it would be the difference between those two numbers. So something along these lines of the difference between the total number of games when you have 11 teams as opposed to 8 teams. And then statement 6, something like this would be how many teams N play if there are a total of 190 games. So you're given the fact that there's 190 games, and this is asking you basically how many teams are needed to play 190 games. So this is just kind of an overview of the function notation based on this context. So now let's look at what the actual activity is that you guys have to do. So I'll let you pause it and kind of read this over. It's also part in you guys' handout, so you can read it on the screen or you can read it in your handout as well. So some key points here is that the plot of land is going to be a square for the flower bed, and that the inside of the flower bed is going to be a circle inside the square plot, and then grass is going to be planted on the part of the square that's not part of the flower bed. And then we're going to account for the different sizes of the flower bed for x. So to kind of give you maybe a better picture of how this looks, let's say this is the office building, and so you have this square piece of land, and inside you have the flower bed. And so we're letting the dimensions of this square be x, so that if you were to change the different dimensions, it gives you hopefully an idea of this little setup, where we don't know what this dimension is, we're just calling it x, but inside is going to be a circle, and the radius is going to be somehow related to the length of the square. So hopefully that gives you a little bit of some context to what this looks like. Okay, so there's some animations, and so what you're going to be basically doing is going through and based upon each one of these sections, interpreting what this expression is going to be. So if this is in terms of x, d is going to be a function that relates x to 4x. So you have to kind of think about what geometric relationship this is going to be connecting. If you have this length of x, what would 4x represent? So you kind of have to think through and then answer those various parts on that. Number 2 is we're going to let r be the radius of the flower bed. And so you have to find a way to relate r in terms of the side of the square, which is based on x, and then answer questions based off of that. And then s is going to be represented by x squared. So hopefully you can recognize pretty quickly what x squared represents, and then how s is related to x squared. And then G's kind of an interesting one, so you really have to kind of think through on that in terms of how you can get x squared and then pi over 4. And the small little hint is that anytime you have pi, you typically have to deal with a circle. And so this is going to be this expression, this equation, this function is going to be relating somehow to this circle. You have to kind of think through that one. And then after that, the 5th one is you're going to somehow relate what s of x and g of x represent. So the difference between these two. So the difference between this one and that one. All right, so hopefully that gives you enough to be able to continue. And you can always contact me for additional clarifications or help via Remind, or it's a lot easier if you @ me. So you have to @ my name on Teams, and I can get a thread going. That way other people can see your responses or see your questions, and we could kind of digitally communicate that way. So if you guys have any questions, reach out, and hopefully you guys are all doing well, and I'll talk to you guys soon.